Okay, let's talk about graphing exponential functions. So notice we have number 1 and number 2. Now, okay, let's talk about the parent graph. So the parent graph for an exponential function, notice that this is the base. Let's just talk about the base. All about the base. This is the base. This is not the base because the 5 does not have a coefficient on it. The 5 does not have an exponent on it. The 5 is the coefficient, but that 2 is the base for the exponential. It is the 1. Notice the 5, it does not have an exponent. The 2 does have an exponent. So here there's no coefficient. There's just a base and an exponent. So if the base is greater than or equal to 1, if it's 1, there's really no graph. But anyway, if it's not a fraction, this parent graph looks like this. It's like an airplane taking off. Okay? Because the base of the exponential is not a fraction. Yeah. So that's like if there's little amoebas in science and all of them replicate every day. One day you have 6, the next day you have 12, the next day you have 24. So you notice because of this coefficient, this is doubling. Okay, it's multiplying by 2. Okay, let's talk about this one. Number 2, the parent graph. This is a fraction less than 1. Technically, the absolute value is less than 1. So the parent graph, this is not an airplane taking off. This is an airplane coming in for a landing. In both of these cases, the x-axis is the asymptote. It gets closer and closer and closer and never crosses the asymptote. Okay, notice this is half. So for example, imagine we were all in class together and I gave you a box of M&Ms and I said, here's your box of M&Ms, eat all of the ones where the M is showing. Can you see that you would eat about half of them, right? Shake the box, eat the ones where the M is showing. So each time if we were to keep track of how many are in the box, number 1, you might get a little sick. But number 2, like if there was 20 and you ate half, then there would be 10 and you ate half. And then there would be 5 and you ate half. And then there would be 2.5. There would never be 0 because it would always be half of the previous number. So whole number as a base, airplane taking off. Fraction, absolute value of the fraction between 0 and 1, airplane coming in for a landing. Okay. So number 2, we're going to make a table. Okay. 2 to the 0th power. What is anything to the 0th power? No, someone always says that. It is 1. You can check that with the calculator. 2 to the 1st power is 2. 2 squared is 4. 2 cubed is 8. Now, this is a great time to reinforce anything to the 0th power is 1. So notice if I go down, I'm multiplying by 2. If I go up, I'm dividing by 2. So if you did with your calculator 2 to the negative 1, you would get 1/2. Notice there is no 0 in the table. That's what creates the asymptote. If you would do 2 to the negative 2, you would get 1/4. Because of that negative exponent, cross the line, change the sign. So we filled out the table. And it would never cross, you would never get 0. It would get smaller and smaller and never 0. So now let's graph 2. So when x is 0, we get 1. When x is 1, we get 2. See how that looks linear? When x is 2, we get 4. Starting to not look linear. When x is 3, we get 8. When x is negative 1, we get 1/2. When x is negative 2, we get 1/4. Then we would get an 8th. Then we would get a 16th. It would never be 0. I missed, but there it goes. Rocket ship taking off. Now, it looks like it's curving up on the left. It's not. It's just getting closer and closer to the asymptote. Okay, so you should know how to plug those in with your calculator. Now let's practice. Number 2, parent graph, airplane coming in for a landing. Okay, table. 1/2 to the 0th power. What is 1/2 to the 0th power? Anything to the 0th power is, careful, 0th power. Oh, careful. Anything to the 0th power is 1. We can talk about why. It's not just arbitrary. It's not just mathematicians said, hey, let's make it 1. I could explain why at the end. 1/2 to the 1st power is 1/2. 1/2 squared is 1/4. 1/2 cubed is 1/8. That is getting smaller. Now let's look at 1/2 to the negative 1. Okay, which is 1 to the negative 1, 2 to the negative 1. Okay, what does a negative exponent do to a fraction? Moves it to the top? Yeah. So this becomes 2 over 1. Do we see that the 2 moves to the top and the 1 moves to the bottom? But a 1 has no value, so it's just kind of a denominator placeholder. Yeah, does everyone see that 1/2 to the negative 1 power flips to 2? 1/2 to the negative 2 power is going to flip to 4. So now let's graph. 0 is 1. Oh, that's the same. Negative 1 is 2. Negative 2 is 4. 1/2, 1/4, 1/8. And it has an exponential, has an asymptote. Gets smaller and smaller and never crosses the x-axis. Okay. We are going to do these at the end, similar on your own, but they're very similar. Number 3, is that going to be an airplane taking off or coming in for a landing? Is the airplane going up or down for number 3? Because the base is a fraction, it's an airplane coming down. Yeah, so don't look at the coefficient, we look at the base. Number 4, is that going to be an airplane going up or an airplane coming down? Up. And we're going to do this at the end. Otherwise, you're going to plug that into your calculator and make a little graph. Okay. We're going to do these at the end. Okay, we're going to go backwards. Let's talk about domain and range. Okay, so we are going to draw a box around the function. Okay, the domain. So 2 ways to write this. We're going to write it using interval notation. So the x values, so domain, those are the x's. The x's go from, what do my x's go from? Is it -5? Is it -6? Careful. The x's, what is the widest x? What is the x farthest to the left? And the edge of the box actually crosses through that. It is not -5. It is -7. Yeah. And on the right end, what is the largest x value that is covered by anywhere in the box? That one's easier to see because it actually hits the axis. Now, we have to decide, does it include the 5 and does it include the 7? If it does include, then this is a firm grip. If these were like empty circles and it didn't include it, then it would look more like an ordered pair. It would look like a parenthesis. Okay, there we go. Thank you. Okay, firm grip. It includes the -7, it includes the 5. What are you here for? Oh, okay, for the review session? Yes, welcome. The packet is right next to the candy dish. It wasn't in that packet that I gave you. Ooh, actually, right, this is the packet that I gave you. That was not included in the packet. All right, now let's do the range. So now let's look at the y values. What is the lowest y value? All right, do we see that it's -2? Yeah, the lowest y value, and the greatest y value is 6. And we include the -2 and the 6, so this is a firm grip. You're like, wait, what if it's not included? We're going to talk about that on the next one. Okay. Number 15. The domain. The domain is the x's, the range is the y's. So we definitely have a boundary for the x's. Now we can see that the x's, there's a boundary on the left, but it's getting wider and wider. There is no boundary on the right. And we can see that the y's, there's a boundary at the bottom, but there is no boundary up above. Yes, infinity is going to be in here. Okay, so how about the x's? What is the smallest x value that gets used in this graph? All right, so -3. Okay, and the biggest x value used in the graph is positive infinity because it gets wider and wider. Now, does it actually include -3? No. So that is a loose grip. It's a parenthesis. Yeah, see the difference? Now, on the right, does it include infinity? You cannot ever touch infinity, so infinity always has loose grip. Okay, the range. What is the lowest y value used in this graph? All right, so -1, and it goes up to infinity. Now notice we actually touch the -1, but you can never touch infinity. Okay, so domain and range. And we're going to use, yeah, those. Okay, now, if you take future math classes, it's very common to see a parabola, and you're going to need the domain and range for a parabola. The domain for a parabola is always -infinity to infinity. Notice forever to the left, forever to the right. The range for a parabola will have a bottom number, and then we'll go up to infinity. The only time this is different is if it's facing down. Then it'll start at -infinity and we'll have a top number. Okay, so what is the bottom number for the range of the graph? -3. And it actually touches the -3. Okay. Now, function or not a function. Now, I apologize. I was trying to save space and I put 2 problems on this graph. Okay. How do you tell if it's a function or not a function? You do the vertical line test. Okay. So we're going to call this line A and line B. They're not really lines, but now for line A, are there any points on this line where the line hits in 2 places? Now it looks like right here, but it's not. Can you see that that's actually a slant right there? This is a function. There is no point in the graph where one x has two y values, even though it comes really close inside that circle. So A is a function. B, nope, it fails the vertical line test. Not a function. Okay, how about number 18? Function or not a function? Can we see that it's a function? Yeah. Now, do you see? Now, this is really important when it comes to piecewise functions. Notice does not include and does include. This is a function. Yeah. So for the piecewise functions, they will never have a point that one x gives you two y. You always have an open circle and a closed circle. Okay. Number 19. I think we started this. We practiced this last week. What is g of 0? So what is the y value when the x value is 0? So when x is 0, the y value is -1. Yeah. What is g of 2? So when the x value is 2, the y value is 1. So that would be -1 plus 1. That would give you 0. Okay, what is g of -4? So when the x is -4, correct. So is 7. Now, this is a parabola. Okay, it is a parabola whose axis of symmetry is the y-axis. So if g of -4 is 7, what is g of +4? It's also 7. Because it's symmetrical about the y-axis. So you'll notice this is kind of weird. This is a week's worth of advanced algebra. You in a normal school, you would be seeing several examples of each of these, but you only have to see me once a week. Okay, number 20. We're going to separate this to g of n plus h of n. And then I'm going to take g of n and I'm going to take h of n. And what am I going to do? Add them. Yeah, I'm just going to add them together. So that equals n cubed minus 5n squared plus 2n plus 1. That's it. Just add them together. Easy peasy. The math is, oh, I have a question. Do I add them? Do I actually combine them into one term? Yes or no? Yeah, Zoomers? Do I actually combine them into one term? So the question is, are they like terms? Let's see, I have an exponent of 3, exponent of 2, exponent of 1, linear term. No. Can we see that these are not like terms? You can only combine them if they are like terms. Therefore, it's done. There are no like terms to combine. The exponent has to match. Okay, now this is different. So this is h of t and g of t. And what am I going to do with those two functions? Multiply them. So I'm going to need a box. So h of t and g of t. I'm going to multiply them together. Okay, fill in the box. For t, what's the exponent going to be on this t? 3. Okay, compare your work with mine. Do I have any mistakes? Am I good? Do I have any like terms? All right, right here. Yeah, like terms. Okay, so 4t cubed minus 25. When I add those, notice my exponent does not change. And there's my answer. I added my like terms. Okay, so we talked about this last week. Odd, even, or neither. So let's remember that an even function, okay, the parent graph for the even function is a parabola, okay, which means you can fold on the y-axis. Yeah, so if you can fold it on the y-axis and it lines up, then it is even. Okay, the parent graph for the odd is x cubed, which means if I rotate it 180 degrees, then it lines up on itself. Okay, number 22, odd, even, or neither? Odd. Rotational symmetry, 180 degrees about the origin. 23. Yeah, Zoomers, what do you think? Brianna, did you have chemistry this morning?
Yeah.
I can tell the difference.
Yeah, like so tired.
Okay, can we fold it on the y-axis and it'll line up? Yes, so this is even. Okay, let's talk about these again. Graphing. What is the parent graph? Exponent of 2 is going to make, yeah, Zoomers, exponent of 2 makes, it rhymes. Exponent of 2 makes a u. What do I find next? According to my way. Vertex. Okay, Zoomers, what's the vertex? So we're gonna go opposite sign, same sign. Yeah, +4, -4. +4, -4. Okay, we're gonna find something new this time. Okay. What is A in this equation? Kind of new. Did we talk about it last week? A little bit? Anyone have a guess? What's the number we haven't used yet? Okay, so the coefficient in front of the x squared, if I were to expand that, A would be +2. Because it's positive, we know it's a happy U. If it was negative, it would flip to an upside down U. Okay. Now, here's a trick, okay? We're not going to make a table this time. On the exam, when you come in, you're going to make a 3-point table, right? The vertex, one to the left, one to the right. But we're going to practice. Actually, okay, I don't want to give you guys into a bad habit. We are going to make a table.
Do we have an exam next week?
Yes. This week is practice exam week. Next week is exam week. Okay, let's put the vertex into our table because we don't want to get into a bad habit. Okay, the x values, one to the left, one to the right. So if 4 is the middle, what else am I going to put into my table? To the left is 3, to the right is 5. Now, I am looking for this value. Okay, you have two possibilities. You could either plug 3 in here and calculate it, or use the value of A. So this is the power of A. 1 to the right, up 2. 1 to the left, up 2. Is that confusing? This is what A is. 1 to the left, 1 to the right. The x value will be negative, but A is up. So we go 3, -2, 5, -2. If you don't like using A, what can you do? Just plug 3 into that equation and you will get -2. I promise.
But if we were to use A, we would have to flip it to the.
Okay. If you look at the graph, you can go up 2. Otherwise, you're going to go negative. You're going to take the y value and you're going to add 2 and it's going to get -2. But it's confusing with the negatives. It's easier on the graph. If you don't like this, you're just going to go do this. If x is +3, you're going to plug in 3. Yeah, and this is going to be -1 squared is 1. Wait, what happened? Oh yeah, -2. So you don't have to use A, but there may come a graph where I show you the graph and I say, what is A? And you just go 1 to the right, up 2, A is 2. So right now, what I'll be quizzing you on is looking at a graph and telling me what A is from the graph. Okay. Okay. Parent graph. What does absolute value make? It makes a V, right? But if A is -3, what is that gonna do to my V? It's gonna flip it. So it looks like this. Opposite, thank you. Okay, vertex. Okay, Zoomers, what's the vertex? Yeah, Zoomers? -2, +4. -2, +4. So let's make a table. -2, +4. Okay, what's gonna go into my table for the X values? So -1 and -3. Yeah, one to the left, one to the right. Okay, Zoomers, I need those two Y values. You can either use A or plug it into the absolute value. You have two different methods for getting the Y values. So take a minute, figure out what those Y values are going to be. Anyone have a Y value for me? Okay, let's do it using A. One to the left. If I go one to the left, what am I doing? One to the left, down 3. Yeah, do you see A right there? One to the right, down 3. We knew that it would be symmetrical. Okay, I'm going to plug in, I'll plug in this one. Y equals -3 absolute value of -1 plus 2, which is -3 absolute value of 1, which is -3 plus 4, which is 1. It works. You can either use A or you can do it using arithmetic. Arithmetic sounds like a sequence. You can do it using arithmetic, but sometimes absolute value can be tricky. Okay, number 26, parent. So the square root, so x squared makes a u. Square root makes a sleeping u. X squared hugs the y-axis. Square root hugs the x-axis. But if it were the whole sleeping parabola, would it pass the vertical line test? So that's what happens because each x can only have one y. So there's the parent graph. What is the vertex? Correct. Yeah, Zoomers, what's the vertex? -1, -3. Okay, -1, -3. What does A equal for this square root function? What is the coefficient in front of the square root? Careful, 0 would make it disappear, right? 1. Okay, now we're going to make a table. So -1, -3. One to the left is -2, one to the right is 0. What happens if you plug in -2? We get square root of -1. Plug that into the calculator. And we get error. It is not a real number. It is an imaginary number. Okay, plug in 0 and you get -2. Can you see A? A is 1. And the difference between the vertex and that very next point has a vertical lift of 1. Okay. Okay. So less is nest, more is or. One of the videos in the notes, the guy, he's like, less is nest, more is or. Okay, so you need to see you don't want to see my face, but anyway, yeah, you see me? Less is nest. If it's less than, the graph is going to look like this. That's going to be our parent graph. More, and you're like, what is that black glove? Don't worry about it. More is or. See how I have ors? Less is nest, more is or. Okay, that's enough of seeing me. Okay, so what is less is nest, more is or? If it's less than or equal to, the graph, well, actually, let's do it separately. Less than, the graph is like your hands going towards each other, and it looks like a nest. Doesn't really look like a nest, but it rhymes with less. Less than or equal to just has included points. Greater than, more is ors. And this is where, if you looked at me, my thumbs actually looks like I'm rowing a boat. So more looks like ors. Greater than or equal to includes the endpoints. So there's a possibility you're going to see a problem on the quiz that says graph. What does it look like? And it might be multiple choice. So what if I don't know a number? What does that graph look like? If it was multiple choice and I had to pick it out. Nest or ors? Yeah. And it actually is good for your brain to like do this with your hands. Okay, so absolute value of X greater than A. Okay, Zoomers, nest or ors? Yeah, it's good for your brain to, it helps you remember if you actually do it with your hands. So I know that this is going to look like this. So if this was multiple choice, I could pick that out just in case that happens in your near future. Using the less is nest, more is or principle. Okay, so let's solve this graph. Parent. Can we predict? Okay. Now, I'm just going to tell you, if there was a coefficient here, you would isolate the absolute value. We're not going to worry about that right now. Okay, so the parent graph, is this more is or less is nest?
Oh, nest.
Nest, right? So this is less is nest. Notice that's not equal to, I'm expecting, this is what my graph is going to look like. Now, I'm going to put step 0 is isolate the absolute value, but I didn't have anything to do there. Future problems. Yes, does everybody see how I got that parent graph? Okay, so now there is nothing to do to isolate the absolute value. Like if there was a 5 there, I would divide, right? But there's not. Okay, so the next step is split. So either 6p plus 8 is less than 56, or the negative of 6p plus 8 is less than 56. Everyone good? Yeah, because it could be the positive or the negative, because the absolute value either takes a positive thing or a negative thing and makes it positive. Okay, so let's solve. -8, 6p less than 48. Divide by 6, p less than 8. Okay, now are we ready for the negative side? We can either, so this is really a -1. We can either distribute it or divide it and make it go away. If you don't like one method, use the other method. I'm going to divide it and not distribute it. So 6p plus 8 is, here's the hard part right here. Okay, we got -56. Now, I just divided both sides by a negative. All right, so my less than flips to greater than. Yeah, whenever you divide by a negative, flip the sign. Okay, subtract 8. 6p is greater than -64. Divide by 6. P is greater than -64/6, which is equivalent to -32/3. Now, in parentheses, which is approximately -10.7. Now, there are a couple different ways to describe how you get the graph. This is technically an intersection. If you need me to explain why, I can, but we're not going to do it that way because we're going to go more is or, less is nest. Okay, so look at this graph. I know that here's the parent, and I know that it's less than 8 and greater than -10.7. Yeah, and it looks like a nest. So can you see that we're going open circle less than 8? So 10.7 is about right there, right? Now, greater than 10.7. Do you see where the nest is? Here it is. It is the intersection of those two inequalities. So over here, we have negative 33, 32 third. Oh, wait, don't do that. Over here, we have negative 32 thirds, and over here we have 8. And it looks like a nest. Do we see the importance of predicting the parent graph? Otherwise, we got to talk about the idea of intersection versus union. We're not going to talk about that. We're going to talk about nest and ORs. Okay, 29. Parent. If you watched last year's video, I didn't call it parent, but I like the way that continues. I just said, what is it? Less is nest or more is or? Okay, so predict what, okay, sorry. Step 0, isolate. There's nothing to isolate, but you might someday have to isolate. Step 1, parent graph. Okay, so we see that it is more. So, and it's filled in, right? More is ors. It's actually called union. Yeah. Okay, so now we're going to split 7n minus 3 greater than or equal to 60. Negative 7n minus 3 greater than or equal to 60. You with me? How are we doing, Zoomers? Okay, solve. Add 3. 7n greater than or equal to 63. Divide by 7. N greater than or equal to 9. Okay. Over here. What's my first step? All right. Divide by -1. So we have 7n minus 3 is less than or equal to -60. Okay, solve. 7n less than or equal to -57. Divide by 7, n less than or equal to -57 sevenths, which is approximately equal to 8.1, -8.1. Okay, are we expecting, now we go back to our parent graph, we're expecting ORs. Yeah, so let's see. Greater than or equal to 9. Oop, this is 8, this is 10, 9 is right there. I hate it when they do that. Greater than or equal to 9. Do we see that this greater than sign matches the arrow? Greater than matches the arrow. Kind of nice. Less than or equal to -57 sevenths, which will be right here. Look at that arrow. And there's our graph. It looks like ORs. It is a union. Oh, and there is one here. That's right. I forgot. Okay, we're going to graph this. Okay, this is going to be on your own because we already actually practiced it. Okay, 31. What's the vertex? Three, -5. Now, A, can we see that A is a fraction? Because it's not going here, it's going up more slowly. So I'm going to say, oh, nope, 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 right here. Can we see that A is up 1/4, kind of like slope, kind of like y equals mx plus b? So A is 1/4. Okay, so here's the equation. First comes, so the equation is A x minus h, sorry, absolute value, x minus h plus k. So y equals 1/4 x minus 3 minus 5, right? The x is opposite sign, the y is same sign. And last one, the vertex is 3, -2. And A is 3. And it's a parabola. Y equals 3 x minus 3 squared minus 2. Opposite sign, same sign. Okay. Oh, sorry. Piecewise. Let's make a table. G of x is x plus 1. So -1 is going to go in both tables. So I'm going to plug in -1 and I'm going to get 0. Okay, now we need to look right here. So I need another x value less than -1 for the first equation. So I'm going to pick -2. Yeah, to the left of -1. So that is going to be -2 plus 1 is -1. So I have -1, 0, open circle, -2, -1, and we can see that it is a line. Okay, g of x is also x minus 3. Make a table. So we're going to start with -1, both graphs. Plug in -1. -1 minus 3 is -4. -1, -4. This one is a filled in circle, right? Now, look at this. I need an x value greater than or equal to -1. 0? Okay, 0 minus 3 is -3. 0 is -3. There is my piecewise function. Notice, is it a function? Yes, because I have open circle, closed circle. Okay, guess what? Do not do. We are done. Okay, so we are done. We're going to go back. If you need to go, thank you for coming. We're going to go back and do the ones we skipped. So if you need to disappear. Okay, starting with number 3. Thank you for coming. I hear people disappearing. Okay, parent graph. So let's say it again. What is the parent graph? Look at the base of the exponential. If the base of the exponential is a fraction, is the graph going up or down? Fraction. Down. This is the M&Ms. I started off with M&Ms and I eat half. Shake the box, eat half. Shake the box, eat half. Okay, so the parent graph looks like this. Notice the 5 is a coefficient. It is not the base. It's not a very good parent graph. But anyway, it's an airplane coming in for a landing. So now let's make a table. So plug -1 into the table. Can anyone predict? Can anyone see what's going to happen? What's that negative exponent going to do to the 1/2?
Oh, flip it.
Flip it. Yeah. Can you see that this is going to be 5 times 2/1, which is 10. Okay, plug in 0. 5 times 1/2 to the 0. What's anything to the 0th power? Careful.
Yeah.
No, careful. Anything to the 0th power is 1. Okay, now notice the 1/2 becomes 1. It does not affect the 5. So it's 5 times 1, which is 5. Oh, can you see the power of the 1/2? I started off with 10 and next I got 5. Okay, it's cutting in half every time. So 5 times 1/2 to the first power is 5/2, which is 2.5. Okay. I like to do the y-intercept first. 0 is 5. -1 is 10. 1 is 2.5. So we could graph more points, especially to the right, but it's a 3-point sketch. And we can see that it's an airplane coming in for a landing. And it never crosses the y-axis. If I took a piece of paper, if we were all in person, I took a piece of paper, divided it in half, divided it in half, I would get really, really small. The paper would get really, really small, but it would never go down to 0. It would just be too hard for me to grab it with my fingers. Okay, unless you guys have requests, continuing on. Notice this function will triple. So parent. Because the base is a whole number greater than 1, it is an airplane taking off. So let's do the 0 first. 2 times 3 to the 0th is going to be what? And then, yeah, anything to the 0th power is 1. Multiply. Notice the 0 only affects the base. Comes down as a 1, multiply by 2, and you get 2. 2 times 3 to the 1st is going to be what? 6. 2 times 3 to the -1. What does the negative exponent do? Flips it. So it's going to be 2 times 1/3, which is 2/3. So we have -1 is 2/3. 0 is 2. 1 is 6. And we have an airplane going up. Okay. 5, 6, and 7 on your own. Solve them just like we did last week. Yeah, I think we're done. Unless you have requests. If you really want, we could do it together. Otherwise, you're on your own. You want to do them?
I think number 11.
Number 11. Okay, describe the end behavior. So last week, we talked about this. Yeah. So number 11. Okay, number 11 looks like this. Okay, so x to the 4th. Can you see that it's 4th degree? But it has a negative in front. So it's upside down. So you just sketch it like this. Notice I'm judging your end behavior, not middle points. Okay, we're not using Desmos. We are using the chart. So that's how those work. Easy peasy. And then 12. These are the same, but they're just with a graph. I would cross them off, but they're just use the chart. End behavior. Whenever you see the words end behavior, that means chart, not Desmos. Okay, it's not supposed to take you 5 minutes. It's supposed to take you 5 seconds. Okay, are we good? All right. And yay, I did record.